Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Hey everyone, and welcome to coding-bootcamps.com. This is the Introduction to NoSQL Programming course. And in this course, we're going to talk about how to create and manage NoSQL databases. Just a heads up, NoSQL is another term for non-relational. You may hear those terms used interchanged throughout the course. My name's Nathaniel. I'm a software engineer with over 5 years of experience, and I'm currently an instructional associate part-time at Georgia Tech, where I help to teach and administer a course on database systems and concepts, where we focus on relational databases or SQL databases. Again, those two terms are used interchangeably. And the prerequisites for this course, there aren't any, which is great. If at any point you feel like we're going too fast, just pause your video and try to catch up. But once you have Mongo installed, which we'll talk about, there are no prerequisites. Just be willing to try to think critically about the examples and reference the documentation. So we're going to talk about getting started. We're going to talk about creating, reading, updating, and deleting data, getting database information, querying for data, update operators, upserts and inserts, collections, which is a common theme throughout the course, but we'll dive into more detail in session 7. Aggregations, count, sum, and other operators that we'll use, and indexes, as well as bulk operations. Note that once you get to session 8, the content gets a little more advanced. So we try to build one session after the next and keep working our way up. So I hope you won't feel overwhelmed in sessions 8, 9, and 10, but definitely consider that fact that the content will become more difficult in those later sessions. I hope that whatever your background is, you are able to come away feeling comfortable using the Mongo CLI, and that you're able to feel like you've got some good code snippets and understandings of creating, updating, managing data from a JavaScript file, and feel like you can go off and keep expanding on that and build a cool application if you so feel inclined. So with that said, please consider these next classes. And I just want to say thank you very much for the opportunity to teach this course. I really hope you enjoy it, and I will see you in the next session. We're going to talk about installing MongoDB Community Edition and running a few basic Mongo commands from the Mongo CLI. The first thing you're going to want to do is open a browser and go to docs.mongodb.com/manual/installation. Identify your platform and go to the associated link. I'm running macOS, so I went to this link and followed their instructions. It's maybe 5 or 6 commands, and that should result in you having a new command available to you called Mongo. I'm not going to go through the installation details because they'll change per your platform. Now that you have Mongo installed and you're able to run Mongo, you'll see some metadata that gets printed out here. The important bit to note is this right here. You're running your Mongo server on your local host at port 27017. I recommend just noting that port right now that you have on your machine, and you're going to use it later on. It may be the same here, but it may change depending on the configuration of your installation. So the first thing we're going to do here is print help. This gives us a layout of all of the different help commands that we can ask Mongo to give us information on. The second section are top level commands that we can run directly. And then this first section are actually commands that give us more lists of help information. So if I run db.help, it's going to give me a whole list of different database commands I can run. But for now, we're just going to run this one, show dbs. You'll probably have a few databases by default with your installation, and I've created a few here already, MyDB, MyDB1, and MyDB2. But you don't need to worry about what's in here already. We're going to create a new one from scratch. So we're going to say use MyDB, and I'm going to say MyDB3. It says switch to MyDB3. If we run show dbs again, we're not actually going to see our database in here because there's no data in there yet. So what we're going to do now is we're going to say db dot create collection my collection. And it says OK. I'm going to say show collections, but before that I'll say show databases again to show you that MyDB3 is actually here now that there's a collection there. We say show collections and we see my collection in there, the one that we just created. Next, if we want to print what's in my collection, we say db.mycollection.find.pretty. And this asks Mongo to print the data in my collection in a nicely formatted way. Now we can see there's not actually anything in here, so we need to insert something. So let's ask DB how to do that. Let's say db.mycall.help per these instructions here to get information on what to do. It says call db.the name of our collection.insert with a document to insert. Now this document is just going to be a JSON object. Whoops. db.the name of our collection.insert. Inserted. Now let's check to see what data is there. We have our data. We have a unique ID for this document, and we have the data key, hello, and value world. Awesome. So at this point, we've basically shown how to get into the Mongo CLI and how to create a database, how to create a collection, which is basically just a category of data, and then how to actually create a record of data inside of the collection, and then print the data in the collection. And in the next video, we'll talk about creating a JavaScript to do some of this same work. We talked about using the Mongo CLI, and I'm going to pick up where we left off and show you how to write a JavaScript that uses some of these same commands to interact with the Mongo database. So I'm going to exit the Mongo CLI. I just did Control-C, and I'm going to show you what's in my directory here. I have a JavaScript file called datadump.js. I'm going to switch over to Visual Studio Code and show you what's in this file, datadump.js. Right here we have a command to print all of our databases. It's going to print it as JSON. Next, we're going to get our database, and we're going to update the name to be our database, which was MyDB3, and store it as a variable called MyDB. The next thing we're going to do is print all of the collections in MyDB. So we're going to say MyDB.getCollectionNames, store it as a variable called collections, and then print it as JSON. And the last thing we're going to do is
say mydb.mycollection.find, and for each document inside of this collection, we're going to print the document as JSON. So if we go back to the command line now, I'm going to go through some of my previous commands to get back here, and I have this Mongo command, the same one we used to access the CLI, with an extra parameter. I'm specifying localhost, colon, and the port number that the server is running at. In my case, it's 2017, and then /test, which is the default server cluster name that Mongo gives you when you install. If any of this information is different, you should be able to just run the Mongo command by itself, and it should show you when the Mongo CLI first starts up. So I'm going to run this command, and I'm going to see that we print all of our databases. We have MyDB3, and we print all of our collections. We have my collection, and we print the data in the collection. We have our data object here, the ID that Mongo gave us, and then the data that we inserted, which is just a key, hello, and a value world. And that's it. In the next video, we're going to talk about CRUD operations with Mongo, creating, deleting, updating different data. See you then. Back again with coding-bootcamps.com, talking about creating, reading, updating, and deleting data with Mongo. In the last video, we talked about writing a short JavaScript to interact with our database and print some data for us. I just want to highlight before we continue that there's a web page, and it should be linked in our notes, called docs.mongodb.com/manual/tutorial/write-scripts-for-the-mongo.shell. This has a breakdown of what I talked about last video, or the video before, about how some of the commands between what you run in the shell and what you run in your JavaScript are a little bit different. It's actually a pretty short list. I just wanted to call this out here so you're aware. It's some of the common commands, like showing your databases. If you do that from the JavaScript, you need to write something a little bit different. But most of the stuff that we're writing in JavaScript, you'll be able to write directly in the command line, which is great. Most of these commands are just high-level commands for showing your database, showing logs, showing users. But when it comes to the stuff we're talking about here, creating, reading, updating, and deleting content, it should be the same. With that said, I'm going to show you a new JavaScript that I've written. This one's called crud.js. And we're only going to look at the first portion of this. Now, this top section here you can really ignore for the purposes of this demo. All we're doing is we're setting our database again, and I'm just going and I'm deleting all of the data from our collection just to get it in a good state that we're comfortable with. So now we know when this runs, we're going to have no data, and then we're going to go and we're going to do a few different things. So, first thing we're going to do, and we're only going to talk up to this point here, this little block of code. So don't focus on anything below that. This is section 2.1. We're going to insert a new document, okay, and we're going to print a message to let us know we're doing it. And we're going to input something that kind of resembles what you might see in the real world. We're going to input an employee document, first name, last name, email, department, password, and location. Don't worry about location right now. This is an embedded piece of data. Just focus on these. If you're new to JSON, it might seem a little strange at first, but it's actually really useful and really easy to get the hang of. Just notice the syntax. You have a key, first name, colon, the value, John in this case. Next thing we're going to do is reference our collection, which for convenience we have up here said was equal to mydb.collection, and we're going to insert our employee record, and then we're going to print done. And that's all we're going to do right now. So the rest of this stuff I'll leave in comment out. So don't worry about any of that stuff, just the stuff we talked about right here is where we're going to stop. So I save this. And I'm going to need to find this
Thanks for watching. Feel free to add your questions as comments down below.
guy. Great. Okay, so we have creating new document, done. And that's all we're expecting to see, creating a new document. And in the next video, we'll talk about reading that document. Hi everyone, this is Nathaniel back with coding-bootcamps.com. And in the last video, we talked about creating a new document in MongoDB. That's what I have highlighted here in our JavaScript. So in this video, we're going to update this document. So what we're going to do is we're actually going to run the exact same code we did last time. We're going to just delete everything from our database with this delete many command. And you don't have to worry about what this is up here. This isn't really important for the demo. It's just, again, a bit of code to make sure that we're always restarting from scratch, just to be clear on what we're doing. So this time we're going to do exactly what we did last time. We're going to create a new document and we're going to print out some messages to tell us that it gets created. Easy. The next thing we're going to do is we're going to come down here and I'm going to uncomment a bit of code that's going to allow us to update our document. It's a really small snippet of code here. And I would advise just to focus less on the syntax, like what the actual command structure is, and just think more about what the command is doing, because you can always come back and reference exactly how to write the command. The important thing here is that we're going to update this exact entity, this document that we just created. So if you look here, we created this this document with an email of johnsmith@example.com and a first name of John. Okay, so what we're going to do down here is we're going to update this document and we're going to give to this update1 function 2 parameters. Okay, the first parameter is a JSON object and it's really simple. All we're doing is we're specifying what are we looking for in our database. We could have a lot of documents. We could have hundreds of thousands of documents in there. And we want to ask, what is it that we're looking for? Well, let's look for an email, johnsmith@example.com. Okay. The next thing we want to say is we want to tell Mongo what we want to change in this document. So we use, again, another JSON object as the second parameter to the update1 function. This is just a little instruction that's telling Mongo that you want to update a field in the data. The next, the value to this set key is the field name we want to update and the value we want to update to. So again, don't get caught up too much on the syntax here. Just understand that we're telling Mongo something we're looking for, and then we're telling it what we want to update in that document. And then we're going to print the status. So let's go ahead and save this and let's run it. Great. So we see that we created a new document and we said done. And then we said we're going to update the document, and Mongo responded because we printed out the result of that update, and it said acknowledged true, matched 1, so it found it, modified count 1, so it updated it. Great. And in the next video, we're going to talk about reading a document, this next bit of code here. Thank you. Hey, this is Nathaniel back with coding-bootcamps.com. In the last video, we talked about updating a document in MongoDB from a JavaScript. And in this video, we're going to talk about reading that document from our Mongo database. So just to refresh on the last video, we created a new document up here with insert. And then we updated that document down here with update1. And now we are going to read the document. So I'm going to just go a little further down in our script and comment out another section of code. So what are we going to do? We're going to print that we're reading the document, and then we're going to look up the document. So we're going to say mydb.mycollection.findOne, and very similar to what we did with our update function, we're just going to provide a JSON object that tells Mongo what we're looking for. So I'm saying that we're looking for the document with an email of johnsmith@example.com. We're going to get that document and we're going to print it as JSON. Simple. And just a reminder that this is going to rerun everything. So as we're working through these examples, we're just adding on one section after another. So when we run this time, what we're expecting to clear out our database and then create the new document from scratch, update the document like we did in the last example, and then read the document. So this time, what are we expecting? Well, we're expecting that we're going to get this employee record printed out, but what are we expecting it to have? We're expecting it to have an updated first name. John should not be John, it should be Johnny Boy, because remember, we're updating the document with the email johnsmith@example.com. We're updating his first name to Johnny Boy. So now when we read the document, we're expecting to see that updated entry. So let's give it a shot. We'll save it here. We'll go back to our terminal. We'll run the same exact script as before. And now what do we see? Created a new document, updated the document. Again, we're printing out the acknowledgement, the result of that update that says that we did indeed modify the document, and now we're reading the document and we have a first name of Johnny Boy. Awesome. So in the next video, we're going to talk about deleting this document. See you then. Hey, this is Nathaniel back with coding-bootcamps.com. In the last video, we talked about reading a new document that we put and updated into our Mongo database. And in this tutorial, we're going to talk about deleting that document. So again, we're going to run all of the same code that we did in the last example, just to keep building off of each video one by one. So quick reminder, we're creating a new document with our insert command. We're updating that document so that we're changing the first name, and we're reading the document, so we're going to print that out again. Just like last video, we're expecting to have an updated name because we've updated the document, an updated first name. And now in this section, we're going to delete the document. So we're going to uncomment out this little section of code. We're going to print that we're deleting the document, and we're going to, similar to all the other commands, we're going to say mydb.mycollection.delete1, and we're going to give it a little JSON object, which again, just like both of the other commands, tells it which document we're looking for. So we're looking for an email of johnsmith@example.com, and then we're going to print the delete status, and that's it. So let's save it again and let's give it a run. Alright, so again, created a new document, updated the document, acknowledged that it was updated, read the document, we see we've got Johnny Boy, and now we're deleting the document, and we see we have acknowledged true, deleted count 1, because again, we are printing out the status that gets returned from the Mongo deleted command. Awesome. So that pretty much covers everything for CRUD. It's pretty easy. Just to look back and do a quick recap, we have this employee record that we are inserting, and we are going off and updating that record here. We're getting the update status as a result of that call to update 1. We're printing the status. We're then looking for that document and printing out the document that we find with the updated data, and then we're going and we're deleting the document here, again providing the information we're looking for and recording that status and printing it out. Awesome. So in the next example, we're going to talk about some other operations that we can do with modifying data. See you then. Hi everyone, this is Nathaniel with coding-bootcamps.com. I hope after the last few videos you have a better idea of how to manipulate data in your Mongo database. And hopefully at this point you're seeing the power of Mongo and just how much you can do and how easy it is. Really, it's just a couple of lines of code to do each of the things that we've been talking about. So in this video we're going to do something slightly more complicated. It actually is really similar to what we've already done, but we're going to basically update this same employee record that we've been working with, but we're going to update this embedded data now. Okay, so if you look at the structure of employee, it's a JSON object, right? You've got all of these key value pairs, but we do have this one interesting bit of data here called location, and location's value is actually a JSON object itself. And this is something where you start to really see how complex and interesting the data you store can get, because you can store documents inside of documents and really just create like very interesting what we call schemas, kind of like the kind of structure of your data and what that looks like. So this here is pretty straightforward, and it's something kind of real world that you might see where you have a location and you're specifying. It's not just a string, it's you've got multiple fields inside of this location. So you've got a city and you've got a state. So we're going to try to update this document. So we're just going to again run everything from scratch, just building off. We're again, just a reminder, just dumping out all of our data at the beginning to start from scratch when we run this script, and we're going to go through and hit all of the same code that we've already done. We're going to create the employee, we're going to update the employee, we're going to read the employee document, and then we're going to delete the employee, right? So that's all fine. We don't need to touch any of that. But now, since we've deleted the employee, we're just going to add them back again. So we're going to say collection.insert employee. So now they're back, and now we're going to say, well, updating document embedded field. This is just a print message that we're going to see to know where we're looking on the terminal. And we're going to do a very similar command to what we did before when we were updating our employee. We're going to say update 1, and this first parameter is going to be exactly the same. We're going to have a JSON object with email of johnsmith@example.com. The next parameter is just going to be a little bit different. We're going to have our set instruction again, followed by a JSON object. Now this JSON object is very similar to what we had before, but it's a little different. The difference is we're going to say location.city and set it to Cincinnati. So just to look back at employee really quickly, if we scroll back up, we're looking for, we want to update location.city, right? So that's the only difference here with this, is we're saying location.city and setting it to Cincinnati, right? So you could have many embedded documents inside of one another and keep saying just location.city, dot population of that city, right? And keep embedding things within each other. But for right now, we're going to just update the city of that location field on the employee to Cincinnati. And for clarity here, we're just going to read it again, as we discussed in an earlier video. We're going to read that same document and print it out just so we can see for ourselves that the update happened as expected. So let's save this file and return to our terminal again. And I'm just going to clear. So we have some So we have some space here, and I'm going to run the same JavaScript.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
So we've got all the same text. We created a document, updated a document, read a document, deleted the document, and then remember, we've reinserted the document so that we can do this example, and we're updating the document with embedded field now. This is the only section of interest. So we have a matched count of 1, which again means that we found it. Modified count of 1 means we modified it. If we look at the document, we have all this data here, we have location, and look what city is. Cincinnati, so we know that we updated the embedded data correctly. Awesome. So in the next video, we're going to keep talking about some slightly more interesting and advanced ways of updating your Mongo data. Awesome. See you then. Hey, this is Nathaniel back with coding-bootcamps.com. And in the last video, we talked about updating an embedded document in our employee document. And in this video, we're going to get into a little more detail about the update and delete commands. So if you notice, this whole time we've been using update 1. We've also used delete 1. Now, this does exactly what it says. It's looking for a record, and then it's going to delete one match, or update one match. What happens if there's more than one? Well, we have different commands for that actually. We have delete many, and we have update many. Now, depending on what key you're using, you might expect many results. If in a real-world example, for instance, you wanted to update all of the employees with a city of Columbus to have a new city of Cincinnati, maybe the department was transferred to a different city, and you want to find all those documents and update all of them at once. Now, for the purpose of this example, we're actually just going to create a duplicate document and show that we can delete 2 at once. So we're going to go down here and I'm going to uncomment out this code. And we're going to print that we're deleting all matching documents. Now, this is just an insert to make sure that we have 2 employees. If you remember, we in the last video, we inserted and updated an employee, so we already have one in our database at this point. And now we're just going to insert a second one. And we're going to go here and we're going to do delete many. And we're going to give it the exact same search object that we have given this whole time, which is just email johnsmith@example.com. But now there's 2 documents. Maybe someone made a mistake and accidentally created many John Smith records, and they want to go through and they just want to delete them all and create a new one. So that's what we're going to do in this example. We're going to delete all of these records that match that search, and we're going to print the delete status. So let's save this and let's give it a shot. Clear again to give some space here, and run this same command, Mongo, with the location of our Mongo server, crud.js, the name of our JavaScript file. And we're going to see all of the same information we've seen this whole time, because we're always running from scratch, just adding on each new section as we go along. But if we look all the way down here, we see that we have deleting all matching records. Acknowledged true, deleted count 2. You would never see that deleted count above 1 if you weren't using deleted many. Similar to how up here we updated our document and we had a modified count of 1. We were using the command update 1. we would never see a modified count above 1. So that's the difference between delete many and delete one, and update many and update one. You have the option to update many matching documents or delete many matching documents. In this case, we deleted 2 matching documents. Awesome. In the next video, we're going to continue expanding on these same topics of modifying data in Mongo. Hey, this is Nathaniel back with coding-bootcamps.com, and congratulations for making it this far through the CRUD section. And we are on our last video, and we're just going to talk about one more interesting aspect of modifying data in Mongo. So we have one last section of code here, and I'm going to go ahead and comment this out. And now we're to the end of our script. So this time what we want to do is we want to build on our last example of modifying or deleting many documents. In this case, we're going to be updating several documents. So since we already have deleted our employee at this point, all of our employee records at this point, we're going to insert 2 new ones. And we're going to print updating multiple documents based on multiple fields. So this first part is very similar to what we did last time. We deleted multiple documents. Now we're going to update multiple documents. We're going to update our 2 employees that we have just inserted here. But we're going to give it a little bit different of a search criteria. Okay, so this is a slightly more advanced example. We're kind of piecing a couple of different things together. So down here, we're going to get the result of this following command: mydb.myCollection update many. Very similar to delete many. It's going to allow us to update multiple documents, and we're going to give it our search JSON object, and this time we're going to give it two fields to query on. We're going to give it email johnsmith@example.com. We're also going to give it last name Smith. So what this is telling us, or what it's telling Mongo, is that we only want to update documents that have an email of johnsmith@example.com and a last name of Smith. So using this, you can just keep adding on comma and then another key value pair, and just keep specifying more and more search criteria if you want to get very specific, if you're looking for a very specific piece of data. In this example, we're keeping it simple, and we know that both of these records have email johnsmith@example.com and last name Smith. If either one didn't have one of these, they would not be included in the update. And this time we're going to update their data similar to before, but we're going to just, for fun, give it a little bit different data here. So we're going to do set again, and we're going to just change the department this time to Narnia. And then we're going to print the updated status. And down here, we're just going to do find. And we're going to talk more about find later, so I'm not going to go into detail about that right now. But the purpose of this command down here is just to print the employee objects so that we can see how they've been updated. So don't worry about this section that I have highlighted. The important part is right here. We're inserting 2 employee documents, and then we're updating both documents based on multiple fields that we're looking for in those documents. So let's save it and let's give it a run. Going to clear for some space and run the exact same script we've been running all throughout this section. And now if we look down at the bottom, just ignore everything up to this point, we're saying updating multiple documents based on multiple fields. Mongo's telling us it acknowledged the command, it found 2 documents, so that's the updating multiple documents part, and it modified the 2 documents. And this is just us showing here what those documents look like now. We have a department of Narnia on the first record, and we have a Department of Narnia on the second record. So the takeaway here is that if either of those search parameters that we had given had a different value, then we would not have updated these documents. And for good measure, I can go ahead and do that really quickly. So you can stop this video if you want, but I'm going to actually change one of these parameters just to show you this. So I'm going to say last name equals Rogers and save it. Okay. Run the same script. Now down here, what do we have? We have the command acknowledged, matched count 0, modified count 0. The email matched, but the last name did not match, so nothing gets updated. Awesome. In the next section, we're going to talk about some more general database commands, how to get more familiar with what the structure of Mongo is and how your data is stored. So I'll see you then. Hey, this is Nathaniel back with coding-bootcamps.com, and in this video we are going to be talking about the Mongo CLI again. So this is a very short section. It's only one video, and we're going to get back into our Mongo CLI by typing the Mongo command. And we're going to revisit a command that we actually did in section 1 to show our available databases. So we're going to say show DBS. So like we talked about here, we have a few default databases, admin and config and local, should all come out of the box with your MongoDB installation. And I've created 5 databases: DB, MyDB, MyDB1, MyDB2, and MyDB3, which is the one that we've been talking about and using throughout this tutorial. So let's try to perform an administrative task here in the Mongo CLI. Now that we've gotten the hang of reading and writing some data to MyDB3. So again, I'm going to illustrate how useful the help command is. I'm going to type help, and I'm going to get a list of methods that are available for the database. Help on DB methods. Now if we look here, there is a command down here called db.serverStatus. So I'm just going to copy this command, and I'm going to paste it, and I'm going to run it. Now there's a lot of data here that gets dumped out, and the more familiar you get with Mongo, and the better you get, you will be able to make use of more and more of this data and understand what's going on here. And I'm sure a lot of this data is more useful. Some of this data is a lot more useful than other data, and we're going to be talking about one bit of data in here, and I'm just continuing to scroll all the way up to where we started, where I ran this command db.serverStatus. What we're going to talk about are the connections that are established and available and have been created with our Mongo server. If we go down here, we see that we have a connections JSON block, and we see that we have one current connection, which is actually our current connection to the Mongo CLI. If we had a script running right now that was connected to our database and was running somewhere, whether locally or in the cloud, that was inserting data and reading data like we've been doing in the past section, then we would have 2 connections. We'd have one for that application or script, and we'd have one for us right now in the Mongo CLI. This shows our total created connections over time since the server was first instantiated. There have been 63 connections. Each time we run that script, each time we use the Mongo CLI, this number goes up. So that's some useful information from an administrative perspective about Mongo. and should come in handy really frequently. Again, there's a lot of useful information in here. Note the host that we're running on,
Thanks for watching. Please like and share this video.
version of Mongo we're using, and there's a lot more. So I definitely encourage you to run this command, just kind of peruse through and see anything interesting, even if you're not really super familiar with a lot of the stuff you see here. You might see some stuff that you recognize, and it might be a good learning opportunity to go through this. So with that said, we're going to end this video and this section. I hope that this gives you more of an idea of some of the administrative things you can do from the Mongo CLI. That gives you more control over your Mongo server and a better understanding of what's actually going on in here, and how is your script that you're writing actually interacting with Mongo. Great, and I will see you in the next section where we're going to talk more about querying data. Thanks. Hey, this is Nathaniel back with coding-bootcamps.com, and in this video we're going to kick off our querying section by talking about two methods that we can use to query data, find and FindOne. So to kick things off, I'm back here on the terminal, and I'm just going to show you that I have a new JavaScript file I've written. It's called queries.js. If we go over to look at this file, I've written a little bit of code that looks really similar to our last example that we used in section 2 for CRUD. So similarly, we're just getting our database, MyDB3. We're deleting all of the data inside of that collection using delete many, which we talked about now at the end of toward the end of our CRUD section. This just gives us a baseline. We're starting from scratch, so we know what we're working with basically. It's nice to get in a baseline state before doing things, especially for examples like these. The next thing we're doing is we're defining an employee again. The schema is the same, just meaning all of these field keys are the same, but we're actually defining two employees. The first one, John Smith, hasn't changed, and the second one is a different employee named Jane Bradley, and she, importantly to note, works in the same department. So all of this information is different except the department. That's what these two documents have in common. So now we go ahead and insert both of our employees. And now this is where our example really kicks off here, because everything up until this point we've really already done in the CRUD section. But now we're going to illustrate the difference between find and FindOne. So in the case that I want to find everyone that works in the IT department, I would want to use .find, specifying department IT, and I would get back essentially a list of all employees, all documents where the record has a department of IT. So I would get back employee 1 and I would get back employee 2. Now the syntax for this can be a little confusing. Don't let it throw you off, but it doesn't actually return a list of all these records. It returns what's called a cursor in Mongo, and it's basically an index. Like, you can think of it like it's a pointer to the first document, right? But there are more than one, so we have to basically iterate over this list of documents. And the reason I want to just emphasize that is because if you just run this bit, just this, you'll get back a cursor. And so if you try to print the result of this, you're not going to get a list of all of the employees that you want. So I'm just trying to emphasize that this bit actually returns a cursor in Mongo, and you have to actually look at that data associated with the cursor in a particular way. So it sounds a little confusing, but really what it means for us is just that after we make this call, we're going to say .for each, and we're just going to put this bit of code in here to tell it to print all of the documents that it finds. So what this is saying is, without going into too much detail about the syntax, all it's saying is that we've found a document in our list and we want to print it. If I wanted to make this function do more, I could just stick more inside of here, right? I could do other things. Okay, so that should give you an idea of how to work with find and for each to loop over all of the data in there. Right now we're just printing the document. Now the difference here, it's slightly more complicated, but it's also very useful what we're doing here. If you use FindOne, it's great if you're querying over data where you only expect one result. You know, perhaps if you're querying by email address and you expect only one person with that email address, it's totally fine. The problem though, and we're going to illustrate this, is that if we find one on department IT, we're only going to get back one record, and it probably will be random. We're going to get back John, or we're going to get back Jane, and maybe one time we get John back, one time we get Jane back. So we have to be really careful with how we use FindOne. When in doubt, I would really recommend using find and just looping over the data, because if you're not sure if you're going to get more than one result back, you should probably assume that you're going to get more than one result back. But let's go ahead and run this example, and we should see that both employees get printed out here, one after the other. We'll find two documents. We're going to loop over both of them, and we're going to print them out. And then the next little bit here, we're going to find one document, and this is going to show us that we're actually only going to get one employee back here from FindOne. So let's save this, and let's go to our terminal, and let's run the same command as before, except I've changed the name of the JavaScript file that we're using to queries.js, and I'm going to hit that, and now we see that we have finding all documents, and we get back both employees that have department IT. But the second part here, finding one document, we only get back John. So I hope this illustrates the difference between find and FindOne, and how you really have to be a little bit careful and think about what data you're expecting back, and always just err on the side of assuming that you're going to get more than one document back. All right, great. In the next section we're going to, or excuse me, in the next video we're going to continue talking about querying data in some more advanced ways. See you then. This is Nathaniel back, here to expand in this video on our last video about the find command. We're going to only use the find command in this video, and I'm just going to talk about a different set of different commands that you can use with the results of find to get some interesting answers from that data. So just to emphasize, if you remember from the last video, I mentioned that when you call mydb.mycollection.find, you're getting back this cursor object in Mongo, and I definitely encourage you to look at Mongo's documentation for cursor to better understand under the hood how this code is working. But again, for our demo here, we're not going to get into too much detail about that. So the first command we're going to use is called limit, and basically what this is going to do is we're going to take the results of find by department IT, and we're just going to limit our results to one. So in our case there's two documents. We're going to limit the result to one, and then we're going to print all of the documents. which in this case is just 1. If we had like 100 records, we could limit this to 10, and then we would just print out those 10. So let's finish going through the rest of these operations because they're all pretty small and straightforward, and then we'll go through the example all at once. The next thing we're going to do is we're going to skip a result. So this is actually going to be very similar to limit, but we're going to specify which how many entries in the result that we want to skip. So we're going to run the same find command, and we're just going to say skip 1, and we're going to loop over those results, and there should only be 1 because we're skipping 1, but we only have 2 results, so we're going to get 1 back again. If I had 10 results and I said skip 1, then I would get back 9. So it's kind of the opposite of limit. If I have 10 results and I say limit 1, I'm going to get 1 back. If I have 10 results and I say skip 1, I'm going to get 9 back. So just think a little bit about that, but they're very, very similar commands. They just are conveniently kind of do the opposite thing. The next thing we have here is a really, really useful one. This is sort. And we're going to run our same find command. And we're going to specify that we want to sort by last name. So we're going to have a key of last name, and we're going to use 1. 1 just means that we're going to sort in ascending order. If we did -1, we would sort in descending order. And then we're going to loop over all of these and print the JSON. So we should expect 2 results here. We're not limiting or skipping anything, we're just sorting by last name. And we should expect that if we look back at our employees, we should expect that Jane Bradley comes first because we're going to sort on last name. And John Smith should come second because B comes before S. And our last operation we're going to do is count. So this one, we're going to take the same find command and we're going to do a count operation. And we are going to count the number of documents that are returned. And I paused for a second because I think this was not exactly right. I'm going to remove that because there's no parameter to count. We're not giving it anything to do. It's very straightforward. It's just counting. So it's going to take this result of find and just count the number of records. We're going to assign that to a variable and we're going to print it out here. So we should expect log statements to guide us through all of the output we're going to get. So we're going to look at limit, skip, sort, and count one by one. So let's save this. And let's run our queries JavaScript file again against Mongo. And let's go up here and see our first one here. So we have finding all documents limiting to 1. We have 1 result. Good. We have finding all documents skipping the first record. We still have 1 result. Awesome. We're going to find all documents and sort by last name in ascending order. We have Jane Bradley first and we have John Smith second. Awesome. That's exactly what we expected. And then we're printing number of documents found. And we have 2. So I hope that gives you an idea of some of the different operations you can do with find to get more insights about your data and slowly be able to build your tool belt around how you can query data. Just these few methods, I mean, you can do a lot of really, really cool stuff. And these basic methods are going to be the most valuable. As you get into more advanced topics, you are probably not going to use some of those things quite as much. So definitely review this stuff, get a good understanding, make sure you understand the difference between limit and skip, and I will see you in the next video. Thanks. Hey, this is Nathaniel back with coding-bootcamps.com. In this video, we're going to talk about using find with conditions placed on the query to filter.
Thanks for watching. Feel free to add your questions as comments down below.
Back the data that we want. So if you recall, we've up until this point always been providing one query parameter. If we just go back all the way back up to when we started section 4 with queries, we were using find and we were always saying I have this thing that I'm looking for, like I'm looking for department IT. But we want to also be able to specify more complex queries that are looking for things with different conditions. So that's what this section's all about. So I'm going to scroll back down through our script that we've been writing, and we're going to start here with and we're going to go through and, we're going to go through or, and we're going to go through in, which is very similar to or. And we're going to go through one at a time and run each of them. We're going to go through and, for instance, and then we're going to run the script and look for our results for our query, our and query, and then we're going to do similarly for the other ones, because I want to make sure that we're focusing on each one specifically before moving to the next one this time, because it's a little bit more in depth than what we did in the last video with the different operators. But it still isn't bad. Just we'll start with and it's actually the easiest one because it's really, really similar to what we've been doing. So we have this find command that we're running, and we're specifying exactly what we did before, department IT. But now we're just adding another field that we're looking for. This time we're looking for last name Bradley. So this is an and. If you are familiar with programming, then this should seem very straightforward to you. It's just an and operation between these two. And if you don't really have much of a background, that's okay. It's a really straightforward concept. All we're saying is that we want both of these conditions to match. We're going to look for someone who has department IT and a last name of Bradley. If you don't work for IT, you're not going to be in this result. If you don't have a last name of Bradley, you're not going to be in this result. And we're going to print out the results. So let's save this and go to our terminal again and run this. We're going to get a lot of output here, but remember, we're just doing one by one. We're looking for the and results. So what do we have here? We have one result that got printed out. And who is it? It's Jane Bradley, IT department. Why? Because if you remember, we have another employee, John Smith, who belongs to the IT department, but his last name is not Bradley. So only Jane gets returned. Now, switching back, we're going to look at or. So again, we're going to print a note to ourselves to let us know where we are. And we're going to run this find again. And this time it's going to look a little more complicated. So all we're saying now is we're using another operator that has this $sign. If you remember, we used this when we were updating data. We did $set. It's just a little syntax that can be a little confusing, but don't worry too much about it. You're going to say or colon, and then you're just going to have a list of different parameters that you're trying to match on. Okay, so the first one is email johnsmith@example.com, and the second one is last name Bradley. So what are we expecting to happen here? Well, only one of these conditions needs to match on a record for you to get the result back. So if we look at the John Smith record, we're going to match on email. All right? John Smith doesn't have a last name Bradley, but we don't care. He has a last name he has an email of johnsmith@example.com. And similarly for Jane Bradley, we're not going to match on email, but we are going to match on last name. And then we're going to print out the results. So let's give that a shot. So if we look here, we have two results. So we did indeed match on both records. Again, for John, we matched on email, and for Jane, we matched on last name. And now our final example, we're going to use in. So in is really similar to or, except it makes it easier to specify if you're looking for one of many different things. That's why it uses the keyword in. It's like one thing in many that I'm looking for. So in this case, we're trying to find a last name, but instead of saying like last name, Adams, last name Bradley, and then another entry last name, X, last name Y, last name Z. If you're looking for a bunch of different possible last names, we can just give one list. So we're only saying last name one time, and then we're using we have colon, and we have the in operator, and then we have a list of different last names we're looking for. So anyone with the Smith last name or the Adams last name will be returned, and I could just keep adding them on here in the list, like I don't know, Jones, right? And so if we could do the same thing with or, but it would get like really big really fast. We'd always have to add a new block for each one. This one's just like we have a list of things we're looking for. So let's give this a run. Okay, and now we see that we were searching for Smith and Adams and Jones, and we get back one record because we only have one person who matched a last name in that list, and it was Smith. So I encourage you to think about this. Don't get too bogged down or overwhelmed in the details of in. The most important things to know are and or. If you get confused with how in is really working and how it relates to or, maybe just take a pause on that one and don't worry too much about it. But if it's making sense to you, then just kind of try to confirm in your mind that you are doing an or here. It's just making it a simpler syntax to you. It's like a convenience method to use. So with that said, we are going to end this video on the logical operators and or and in that we're using to filter data, and I will see you in the next video. Hey, this is Nathaniel with coding-bootcamps.com, and congratulations on making it to the last video of the querying section. And this is going to be a relatively easy bit of content, and also a very useful one. So with that said, let's get started. So we're working in the same JavaScript file that we have been working on throughout this section. We have the same find command that we are running, and we have the same query parameter that we ran initially, department IT, expecting to get back the 2 employees because they share that bit of information. And now what we're going to do is we're just going to tell Mongo that we don't want all the fields back. We just want the first name and the last name. And the syntax here is pretty straightforward. You see we have the comma here after our first JSON object with the query, and everything that comes after that comma that's in these brackets is the projection that we want. And a projection is just telling Mongo which fields we want to get back. So I'm saying first name, :1, we want the first name back. Last name, :1, we want the last name back. So all other fields shouldn't be in our result. We're going to print a little message to ourselves, finding all documents with projection. And we're going to loop over these documents we find, similar to what we've done before, and just print each one out. So let's save it, and let's give it a run. Oops. So this last block is what we're interested in, finding all documents with projection. And we can see here that we're getting results back like we've gotten before, except this time we're only getting first name and last name. We're getting John, Smith, and Jane Bradley. So again, if you look up to other results we've printed out, we're getting the whole block of data, But maybe we're just interested in first name and last name. Maybe we have a dashboard of employees and we just want to list their name. We don't want to list their location and other stuff like that. So this is a really handy operation to have. And don't be too concerned by the ID field here. This is something that, as we mentioned in section 1, Mongo assigns to every document record. And it's a primary unique identifying key. That's always going to be included in your projection. And you can see here that it's got this underscore ID, which Mongo is processing as like a standard default field that it has, and it's not going to matter whether you specify ID in your projection or not. It's just always going to show up. So don't be concerned by that. And with that said, we're going to close out our section on querying. Thanks so much, and I will see you in the next section. This is Nathaniel returning for coding-bootcamps.com. We are in section 5 of the MongoDB course, and this is going to be a very brief section. We're going to talk about the set operator for updating documents in your Mongo database. So what I have open here is our CRUD JavaScript file, which we built in section 2. And we're going to actually just modify one of our update commands in here to illustrate how set works in a little bit more detail. So what I've done is all of this is the same here as it was in section 2. We're clearing out the database and we are creating a new document that we're inserting here, and we are updating the document. We're looking for the document with email johnsmith@example.com, and then we are updating it with this set operator, updating the first name to be Johnny Boy, and then we're reading the document, just finding the document with that email and printing it out. All of that is the exact same as what we did in the section 2 tutorial. Everything else that happened in the section 2 tutorial I've just commented out because we're just going to modify this little piece of code here. Okay, so for illustration, let's actually go ahead and just run this again real quick. Remember, what we're looking for here is Johnny Boy, the first name on the employee, John, being updated. So let's run this real quick. We're going to run our file, crud.js, and we're going to see that we created a new document. We're updating the document. We did indeed update it, and we have Johnny Boy there. Awesome. So remember, this set syntax is specific to Mongo, and don't let it confuse you, right? We know that we have an update command, and we have our query, then we have a comma, and then we have another JSON object. Now, this JSON object consists of the keyword set followed by another JSON object with the actual data we want to update, right? So to make this look a little clearer, let's actually just do this. Right? This is what we're setting. The first name to Johnny Boy. Okay? Now let's make it even more clear. You see that? Everything we're updating we can just stick here. So let's actually update the last name too. Just something random. Prometheus. Sounds cool. Johnny Boy Prometheus. Had some interesting parents to give him that name. So we're expecting now that we're going to, again, clear everything out, create John Smith, and now we're going to update this record matching that email. But we're going to update 2 fields this time, and we're just adding them to that same set JSON object, first name and last name. So let's give it a run. Make sure we save it, Now I'll go ahead and clear this out so we get a little more space here. CRUD.js, we'll go ahead and run that. And we see we've modified the document, and we see we have first name Johnny Boy, last name Prometheus. So I hope that gives you a better idea.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
Idea of how updates work and how you can update multiple fields off of the record that you find, that you query. And remember, we're using update 1 here. You can do the same thing with update many. You can do update many and provide some data to match on, like we've already talked about throughout this section. You can, make it, a more complicated query with ands and ors. You can find all of the employees who work in Chicago, Illinois, out of a big group of 1,000 employees, and then check if one of their last name matches in a list of last names, and then you can update specific data. You can update their password, you can update their email address. So you can build these more complicated workflows just from this set of CRUD operations we talked about in section 2 and this set of queries that we talked about in section 4. So now I hope that with this video in section 5 you get a better idea of how you can update more fields on the objects that you query when using update 1 or update many. With that said, I will see you in the next section. Hey, this is Nathaniel back with coding-bootcamps.com, and in this section we are going to be talking about upserting data. So we're back here in our CRUD file, picking off from where we left off in section 5, where we inserted an employee and then we were updating multiple fields in that employee record. And we've got everything else commented out in this file. All we're doing is again clearing the database, creating a new document by inserting it here, and then updating that document, both of these fields, first name and last name. But you'll see here I've added one little bit of code, upsert. So upsert basically is telling the find command, or excuse me, the update command, that if this record exists, we want to update it. If it doesn't exist, we want to upsert it, which means we just want to create it in the database. So what this means is we should be able to run this command and get the exact result that we got in section 5, which is we should get the employee with his first and last name updated. We're creating him here and updating the document. So this should not change anything that happens in this script, and this is all that we've added since we did this same example in the last section. So let's save that and let's return to our terminal and run our CRUD file again. And we see here that we have our record with the first and last name updated. Awesome. I'm going to clear the terminal and we're going to go back to our JavaScript file. And now you see this one statement here where we insert the employee. We're going to remove this. Oops. Just comment it out. What are we expecting to happen now? When we get to the update, the employee does not exist. We're expecting for the employee to be created. Just make sure I've saved the file and let's run it. And here we go. see we have updating document, acknowledged true, matched count 0 instead of 1 because we didn't find a document, upserted ID, which is the ID of the document that Mongo is assigning to us for the new document we're creating. So this one update command is not finding the document to exist. So matched count is 0, modified count is 0, but it is upserting it. So it's just creating it. And we get that ID back. And when we go and read the document, we see the same ID ending in 37 right here. This is the one we've created, Johnny Boy Prometheus. And just a reminder that if we go back here, nowhere in here are we inserting an employee record. We're defining the employee and we're updating the employee with an upsert flag, telling it if this employee doesn't exist, then just go ahead and create him. And then we're printing the result down here. And with that said, I will see you in the next section. Hey everyone, this is Nathaniel back with coding-bootcamps.com, and we are going to begin a new section talking about creating collections and dropping collections in your Mongo database. So if you remember, up until this point, we've kind of just been working with the same database we created in section 1 and the same collection within that database that we created in section 1. So we're going to go back to the Mongo CLI and just explore a little bit more about our database and about what collection we've been using, and show how to create a new collection and drop a collection. So first thing I'm going to do is type Mongo, and we're going to use our trusty show databases command, and we will see that we have our database MyDB3 here. So we're going to say use MyDB3, and now I'm going to print show collections, and you'll see we have my collection. And if you recall, this is the collection we've been using throughout the demo. All of the data that we've been reading and writing has been going to MyDB3 and my collection within MyDB3. I'll just switch over to our script real quick and just illustrate that. If we scroll up to the very top, remember we've always been setting this MyDB, MyDB3, collection, MyDB.myCollection. So we could create a new database, we could create a new collection, and that's exactly what we're going to do. We're going to create a new collection in our database MyDB3. So again, I'm going to just illustrate that we can use our help command to get all of the information we need. And this actually contains most of the documentation you'll find in the Mongo docs online. So we say help, and then we want to figure out our collection methods. So we say db.myCollection, the name of our collection. Excuse me, I'm sorry. We are actually going to do db.help because we want to get the database level commands, which will have the right command for creating a collection in the database. So we see we have db.createCollection, and it takes a name. And there are some other parameters we can provide here, but we're not going to use those right now. We're just going to create a new one with a name. So let's call it test1. I click enter, and we see a status of OK, and I say show collections, and we see we have a new collection. So now we have my collection, which we've been using, and we have test1, which is a new collection. And in the next video, we'll talk about dropping a collection from a database. This is Nathaniel back with coding-bootcamps.com, and in the last video we talked about creating a new collection for our database. I'm back here in the Mongo CLI, and I'm just going to walk through again, switching into our database. You see again, if we run our show databases command, we have our we have our database MyDB3. I'm going to switch to that. And I'm going to do show collections as we did last video and see that I have my test1 collection. So we're going to go ahead and drop this collection. We're going to run the help command to see how to do this. We see that in order to get help on our collection methods, we need to run db dot the name of our collection, which is now test1 dot help. Oh, excuse me. Yes, dot help. There we go. And we can see here we've got all of the different commands we can run for this collection. So everything is prefixed with db.test. We're looking for db.test1.drop. It says drop the collection. That's exactly what we want to do. So I'm going to copy this and I'm going to paste it in and I'm going to click enter and we get a status of true. If I say show collections, we'll see that I only have my collection. Great. So that wraps that up. I hope that this gives you some idea at a higher level of how collections work within a database. Just keep in mind that we've only been using this one collection here that we've created in MyDB3 or whatever the name of your database is that you're using. We've only created this one collection and used this one collection throughout this course. So just a quick reminder, if you look at your JavaScript that you've been writing throughout this course, you should see at the top, remember we created variables for the database and the collection we were using. So we haven't really thought about it this whole time. We just said, hey, get MyDB3 or whatever database you're using, and then hey, our collection is mydb.mycollection or whatever collection name you were using if you chose a different one. Oops. So just keep that in mind. We haven't really been thinking about it this whole time, but you can indeed create new databases and use those databases from your JavaScript by changing this variable. You can do the same thing with new collections and change the collection you're using with this variable. And if you think about it from the context of using employee records in my collection, we could also create a collection for something else, maybe departments. And so more and more we have collections that kind of resemble the different data that you might be interested in a company. So my collection is used for employees. We could create my collection 1 and we could have it used to store different departments, or we could have it used to store different products that we sell, different inventory. And I think you get the idea. These collections can be used to separate out and categorize the different documents, the different types of data that you're storing in your database. Now, with that said, that ends our section on creating and dropping collections. I will see you in the next section. Daniel here with coding-bootcamps.com, and in this section we're going to be talking about data aggregation in MongoDB. And what we're going to do in this first video is just talk a little bit about what aggregation means, and then we're going to show you the simplest form of doing an aggregation in MongoDB. So we're looking here on my screen at the documentation that MongoDB has for aggregations, and we can see that they say aggregation operations process data records and return computed results. Aggregation operations group values from multiple documents together and can perform a variety of operations on the group data to return a single result. Now, the key takeaways here are that you're looking at a lot of different records or documents in your data, but you're returning a single result. So the simplest example of this is actually something that we've done already. If we look back at our queries.js file, you remember that in this section 4, we had used an operation called count. You remember we looked at our records who had department IT, and then we got a count from them. Now, this is an aggregation. Why is it an aggregation? because it hits on the two key points that we just mentioned. It's looking at many different results from our data. Remember, we had 2 records that have a department of IT, but then we are only returning one result. We're returning the count of that data. So in its simplest form, this is an aggregation.
Thanks for watching. Please like and share this video.
We're getting back a number. We're getting back one thing, but we're looking at a lot of different records. So I hope that explains at a high level what data aggregation is. It's a really incredibly valuable concept to know in software engineering, big data, and data science. And it really is as simple as looking at a lot of data, or looking at really more than one piece of data, and generating one result from that data. And in the next video, we'll start expanding on different types of aggregations that you can do beyond this simple example of count. I will see you in the next video. This is Nathaniel back with coding-bootcamps.com. In the last video, we talked about the most basic example of an aggregation, which is a simple count function available on a collection. In this video, we're going to get into a little more depth around the functionality that MongoDB provides for aggregations. Because the thing is, when you're doing a simple count of collections, there's a very simple method for you to specify that you want to count all the records or documents in a collection. But now I'm going to show you a different syntax that we're going to use for the remainder of this aggregation section. So I've switched back into our text editor, and we have a new file called aggregations.js. Pretty similarly to the other JavaScript we've written at this point, we are declaring our database, we're declaring our collection, and we're deleting any records that might exist just to avoid confusion. And then we're going to define 3 new employees this time. We have our same John Smith, we have our same Jane Bradley, and we have a new employee, Fred Jones. And you'll also notice that we've defined a new field for each of them called salary. So in this example, what we want to do is we want to sum everyone's salary together. This might actually be a really practical, real-world thing you would want to do to figure out your payroll. You could query your data and figure out what your monthly or yearly rather expenses are in the payroll department. So what we're going to do is we're going to insert all of our employees, 1, 2, and 3, and then we're going to print a message to ourselves to say summing all employee salaries. Now here's where things get a little tricky, and you might need to pause the video along the way just to reference the documentation and make sense of this syntax. We have our database, and we're saying dot our collection name, my collection, as we've always done. And now we have a new command called aggregate. Now, aggregate is an array because there are many different aggregations that you can run as part of the same pipeline. We refer to this whole object here, this whole array, as a pipeline. And the reason it's an array is because you have pieces of the pipeline that come one after another. So you can think of it just like a straight line, where if we define another thing right here, we would have a second object in our array, and so that would become the second piece of the pipeline. So right now we just have one piece of our pipeline. It's a pipeline with one object in it, this thing. So what we're doing is we're specifying that we want to group our data by ID, and we want to construct a new field that does a sum operation on the field salary. this field up here, salary. So the syntax might be a little confusing. I encourage you to look at the documentation. One thing to note is that you do need this group operator. Now, we're not actually going to group by anything. All we want to do is get the salary of all of the employees. That's why this is blank. Really, the only thing we're looking at here is this. The rest is just syntax we need to get the aggregation working. So only focus on this part. We want to say, we want a result that tells us in JSON a field total with the sum of all the salaries. So let's just do that, and then we'll expand on this a little bit more. So if we go back to our terminal, we'll run aggregations.js, and we'll see we have our message summing all employee salaries, and we have our total, 178,000. ID is blank. We're not grouping by anything. Now, if we wanted to change this slightly, we could add a grouping here. You'll notice that employee 3 belongs to the accounting department, while the other 2 belong to the IT department. If we want to group on a specific field, we can get different aggregation results for those fields. So by leaving this blank, we're telling Mongo, we don't really care. We don't want to group by anyone. We just want the total salary on everyone in the collection. But if we put department here, for example, and saved our file, return to our command line, and run the program again, we'll see that we have an ID of department. And excuse me, I actually made a mistake here, so I'm going to backtrack. Let's delete this. Okay, so we are just summing salary at this point. We actually want to put the name of the department. We want to actually put a $sign prepended to the name of the field, rather. There we go. I apologize for that. So now we see that we have our total being listed again, but this time it is grouped by the different departments. So we see that accounting 63,000 and IT 115,000. And just to clarify, since I made a little mistake there, these fields have to have a $sign prepended to them. So our department field, we've prepended with a $sign. Our salary field, we've prepended with a $sign. We are saying sum all of the salaries of all of the documents that belong to a particular department. Awesome. I know this one is a little more involved, so I definitely encourage you to look at the documentation, take some time with it. Don't get overwhelmed by all the syntax, and we'll continue to expand on the different types of things we can do from this aggregation pipeline. I will see you in the next video. Daniel back for another round of aggregations for coding-bootcamps.com. And in this video, we are going to talk about the aggregation operator average. As you saw in the last video, we had a JavaScript where we were specifying an aggregation pipeline. And inside of that pipeline, we had an operator here for sum. Now, we're just going to change this to average. And you can see I had already changed it, but you get the idea. We are switching these 3 letters from SUM to AVG. That is the only change from the last video. And we are still grouping by department right now. And we're going to save this, and we're going to view our result. Running the same aggregation script, we see that we have our IT department with an average of 57,500 and our accounting department with an average of 63,000. If we want to check our results, let's return to our code and look at our employee salaries. There's one employee in accounting. They have a salary of 63,000, so the average is 63,000. We have two employees in IT, one with 44,000 and one with 71,000. If you do a little bit of math, you will find that the average is, if we return to our terminal, 57,500 for that department. And that's it for this video. In the next video, we're going to continue talking about more aggregation operators and how to make our aggregation pipeline a little bit more sophisticated. I will see you then. This is Nathaniel here with coding-bootcamps.com, and in this video I'm going to be talking about how to use an aggregation pipeline to do array operations. So as you can see, I've written a little bit of code here in our same trusty aggregate command. We have one stage in this entire aggregation pipeline. I've formatted it a little differently for clarity, and we can see here that we are performing an operation on each document in the collection. And what we're going to be doing is we're going to be creating a new field, and we're going to be performing the concatenate arrays operation on skills and hobbies. So we have these two fields on employee skills and hobbies. Perhaps for whatever reason someone wants to run this aggregation to get all of everyone's skills and hobbies in one list and compare them for some fun team building activity or something like that. So we can do that with this little snippet of code, and we'll go ahead and run this. And we can see here that we get a list of employees with each employee having an items field with all of their skills and hobbies together. So we've created the result of this aggregation is a document for each employee with their unique ID and a list of items that consists of their skills along with their hobbies in the same array that's been merged together. That said, I will see you in the next aggregation video. This is Nathaniel back with coding-bootcamps.com. And in this video we're going to continue exploring aggregations in MongoDB. This time what we're going to do is we're going to change our aggregation pipeline, and we're just going to use a different operator. And what we're going to do here is we're actually adding a new employee, employee 4, just to make the example a little bit fuller. We're adding Tom Wilbert. He's got a salary of 110,000, and we're going to add all of our employees, 1, 2, 3, and 4, and then we're going to aggregate and specify that we want to sort by salary. Now you might recall that we actually sorted based off of a field in employee in a previous lesson. And we didn't actually use the aggregation pipeline. Instead, we simply directly specified that we wanted to sort on the collection without using this aggregate keyword. And for clarity, we can actually just go and find that real quick. I'll show you. This is back in our queries.js file. And we see that we had sorted by doing a find and then a sort by last name. Right? There's no aggregation pipeline. What we're demonstrating here is that we're doing something similar to that, we're going to get a similar answer, but we're doing it from the aggregation pipeline. The reason this is useful is that, remember, the aggregation pipeline, we can continue appending on many different pieces to the pipeline. Right? I can add another thing down here and just keep going and keep doing operations on my data. It's incredibly useful. And in this case, we're just specifying that we want.
Thanks for watching. Feel free to add your questions as comments down below.
To sort, this time based on salary. We're not doing a find or anything like that, so there's no filtering that we're doing. If you remember in queries.js, we were first finding on department IT. So what we're expecting here is simply that we're going to sort all of our employee records based on salary. So if we go back to the console, I'm going to clear and get things fresh and scroll back up. I'm running our aggregations.js file, and we'll see that we have all of our employees starting with John Smith at 44,000 all the way ending at Tom Wilbert with 110,000. So I hope that gives you an idea of some more different operations you can use inside of the aggregation pipeline. And yeah, I definitely recommend just thinking a little bit about different types of aggregations you could run. What's another operation you could run after sort on your data? Go ahead, think of one, add it in here, and see what your result is. Great, I'll see you in the next video. This is Nathaniel back with coding-bootcamps.com, and in this video we're going to pick up where we left off talking about the aggregation pipeline and how you can add more operations into it. Specifically, we want to talk about this one operator, which is really useful. If you remember what I was talking about last video, over in our queries.js file that we had written in a previous section, we were sorting, and before we sorted our data, we were actually specifying a parameter to look for. So we weren't getting all of our data and sorting it. We were only getting employees in the IT department and then sorting based on their last name. So we're going to do something similar to that, but again using the aggregations pipeline. So in this case, we're going to use the match keyword, and we're just going to specify department IT, and then we're going to use sort, and just like in the last video, we're going to sort in ascending order on salary. So if we save this and go to our terminal and clear this data out, and just think, you can even pause the video, what data are you expecting if we're matching on IT department and sorting by salary? How many employees will be returned? And what do you expect the first and last salaries to be? So we see we have 3 employee records because, again, we're matching on the IT department. And we are sorting by salary. So we see that the lowest salary is first, the next salary is next, IT department, and the last salary is the highest, and again, IT department. So all 3 employees are in the IT department, and we sorted by salary. Mission accomplished. And we're going to continue on in aggregations in the next video. See you there.
This is Nathaniel back here with coding-bootcamps.com, and in this video we're going to talk about deduplicating documents with an aggregations pipeline. So I have here a new aggregation that I've written, and we're going to talk about in just a second. But before we do that, I just want to note that I've created a new employee record here, Tom Wilbert. It's an exact copy of employee 4. And this is simulating perhaps someone making a mistake and adding a duplicate document that we want to delete. I'm adding him in down here with this insert employee 5. So at this point, before we run this aggregation, we have 2 Tom Wilberts. So this aggregation pipeline consists of two stages. The first stage, we're going to group by email. So if you have the same email, we're going to get two of you in this grouping, in this new, essentially this new temporary collection that we're creating. And then we're going to match on those that have a count greater than 1. So for those specific groupings, which in this case we're expecting one grouping where we have employees with the same email, so we have a grouping with more than one record, and for that one grouping that we find, we're going to iterate and we're going to shift one of them and remove the other. I encourage you to look at the syntax of this and reference the docs. I don't want to get bogged down in the weeds of this syntax here. So reference the documentation if you're curious, but the important thing to know is that by the time we get through this aggregation pipeline, we have one result, and that result is the group of emails where we have the same email being used more than once. So we have one grouping with two records, and we iterate over that grouping and we remove one of them. At the very end here, we print the result to show that we have 4 employees because the duplicate Tom Wilbert has been removed. So let's give this a run real quick. I've saved it, and just to remind you, we have our Mongo command, the host and port, as well as the default server, test, and aggregation.js, the name of our JavaScript file. So I'll hit enter, and we'll see here that we have John Smith, we have Jane Bradley, we have Fred Jones, but we only have one Tom Wilbert, even though we inserted him twice. So we see that our aggregation to deduplicate a result with the same email has worked. And with that said, I'll see you in the next aggregation video. Nathaniel here again with coding-bootcamps.com, doing another aggregations video. In this video we're going to talk about the lookup keyword in an aggregation pipeline and how it's used to join two collections together. So for the purpose of this example, we have our 5 employees, and we're basically asking Mongo to add a new field to each of these employees with some information about their department. So we're saying that we want to connect our field, basically, or join it, the field department, this one, to a field called name in a department's collection. And then whatever's in that associated entry, put into department info. So I've written this little snippet of code, but if we run this, you'll see we're not actually getting anything back yet in the department info field because this collection that we're trying to join on doesn't exist. So now what we're going to do is we're going to go into Mongo, and we're going to use MyDB3, and then we're going to say show collections, and we see we just have the one collection. So what we're going to do now is say db.createCollection, and we'll call this, let's look back at what we want it to be called. You see in the from field, we're calling it departments. We're working a little bit backwards this time. Then we get a status of OK. And now let's go back to our JavaScript. We're just about done there in the Mongo CLI. It was just most convenient to create the collection there. Now we have a new collection. It's part of the same database, so I'm just going to define that up here. And we'll name this one a little better this time. We'll say departments.
is MyDB, that department's. Now, after we've cleared out our database, we'll go ahead and just give some definitions for the two different departments we have. So we have accounting and we have IT. Okay. Now the most important thing we need to add to these, the data going in this new collection, is name, because that's what we're going to match on. I want it to be the exact name of the department we're trying to match on. And we just have these two. Oops. And if I'm going a little too fast, feel free to pause the video and maybe rewind and just so you can catch up to where we are. But right now, we're defining our new collection that we created from the Mongo CLI, and then we're defining two new documents that we're going to stick inside of that collection, the departments collection. And now, what do we want to add here? Because the whole point of this is that we wanted to add some extra data associated with our departments. So let's maybe just give it a department ID. That can be pretty common at big companies. Department ID 123, and maybe a manager name. I don't know, Stacy, Brock. And I'll just copy this section for efficiency's sake and paste it in. Change the ID, change the manager, so now accounting has name accounting, ID 123, and manager Stacy Brock. IT has name IT, ID 321, and manager Catherine Donald. So now what we're going to do down here is we're going to add these. And we're going to add IT as well. Okay. So we're expecting that before this aggregation begins, we have all of our employees, and then now we also have two department records. And the expectation is that when we do this lookup, we're going to be able to find that table called, or that collection, as it's called in Mongo. Going to be able to find the departments collection, and we're going to be able to match our department field to its name field. And that's really the crux of this. We want to match our department field to its name field. And then we just want to make it called department info. And it's just going to contain all the info that we get from that department record in the collection. So, assuming we've not made any coding errors, which we very well may have, we should be able to run this script. And there we go. First try. As you can see, we have all of our employees listed. This is John Smith. He's in the IT department. And we get his department info down here as a new field. And this is not in my collection, the collection that has the employees. This is in a separate collection, but it's getting joined on to each entry. Name IT, which we're matching on. And that really is the key that you have to keep in mind. We're matching department with name. Manager, the ID of the department record, the unique Mongo ID, that is. We've given it a separate department ID. And each employee has the same. And that's it. And we'll continue where we left off with aggregations in the next video. This is Nathaniel here, back with coding-bootcamps.com. In this section, we're going to be talking about performing an aggregation from the Mongo CLI.
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
As you can see here, we're back in our JavaScript just for the moment to kind of look at this aggregation again. It's the same one we ran in the last video. We want to basically just run this from our Mongo CLI, just as a demonstration of the fact that you can really use the Mongo CLI for quick data lookups, data aggregations from a system administrative perspective to try to figure out what your data looks like without having to run a full JavaScript to do that. So if you get good with the Mongo CLI, it's really incredibly helpful, both from an admin and from a debugging perspective. So what we're going to do is we're going to switch over to our command line, and we're going to enter the Mongo shell. And we're just going to go through our basic routine of showing our databases, and we're going to use MyDB3. Now, the great thing is the command is going to be almost the exact same. So I'm actually going to copy this whole thing. The only difference is that MyDB is going to change to just DB. Because remember, MyDB here in this JavaScript file is defined as MyDB3. In the CLI, when we type use MyDB3, as we just did, we switch the context to that particular database. So there's no reason to get our database and then use that to make the call. So we're going to copy this whole portion here, but we're just going to use our generic DB name. Because again, this is just saying use the database that we're in the context of, which you can see here is MyDB3. And then I'm going to paste the rest of that. And I'm actually going to exit out of that because the dot, there was already a dot there. So I'm going to do DB and paste, and that's what we want. And we see we get back the same aggregation results that we did from our JavaScript. And this is where we ran our command, and we have all the same information as in the last video for the department info. Awesome. And that wraps it up for this video. I'll see you in the next one. This is Nathaniel back for coding-bootcamps.com, and in this video we're going to kick off our talks on indexing in MongoDB. As you can see on the screen here, we have some documentation from Mongo, and I want you to keep in mind, especially if you're new to databases in general, indexing is a slightly more advanced topic, and it's still relatively easy to understand at a high level what indexing is and how it's helpful. But unless you have a background doing database development or administration, I wouldn't recommend getting too bogged down in trying to understand exactly how indexes are implemented. So I'm just going to read the first part of this from Mongo, and then we're going to leave the rest out as it gets more into implementation. Indexes support the efficient execution of queries in MongoDB. That's why we use them. They're strictly for efficiency. Without indexes, the MongoDB must perform a collection scan, i.e. scan every document in a collection to select those documents that match the query statement. If you remember when we were using find to query over our collections for specific records that matched our query, what Mongo is doing under the hood is it's looking at every single record, looking at each of the fields that we specify and seeing if there's a match. So it does not scale very well if we have a very, very, very large set of data that we have to scan over. This is why they say if an appropriate index exists for a query, MongoDB can use this index to limit the number of documents it must inspect. So let's go ahead and just create an index. We're here in our Mongo CLI again, and we're going to use MyDB3. And we're going to do help, and we're going to get help for our collection, because this index will be created at the collection level. All right, so we have our list of help commands, and if we go up and see, we have an option to create an index. It's going to take all of the keys that we want to index on, that we basically want to keep a little list of, to know, hey, which employees are in the IT department. So we can just look at that list if someone is trying to search by IT department. So we're going to paste this command. We're going to say department. And we're going to specify what type of data Mongo is going to be indexing. And we're just going to say text, because our departments are defined as text in our employee entities. And there we go. We have number of indexes before. This was likely a default index that Mongo had defined. And number of indexes after 2. Status OK. So now we have an index. And in the next video, we'll continue expanding on the concept of indexes and talking more about different use cases. See you there. This is Nathaniel back with coding-bootcamps.com, and in this video we're going to be talking about how to delete an index, picking back up right where we left off in the last video after creating a new index for the department field in our employee collection, which is called My Collection. Now, what we're going to do here is we're going to reference back up at our help and see that we have a command here to get a list of indexes. I'm going to run this command, and I'm going to see that we have a couple of different indexes here. One is an index that is predefined by Mongo. We're going to ignore this one. It's just an index on the ID field. And the next one is ours, which we had named for us as department_text. It just took the field that we're indexing on and the value, the type that's in that field, which is text, and put an underscore in between them. That's all it did. Next thing we're going to do is scroll back up and look at our help, and we're going to see that we have a command to drop an index. So we're just going to copy this, and we're going to look right here. It says, gives us a little example, db my collection drop index name. They make it very simple for us. And of course there's another method that you could use to drop an index, but we're not going to do that because we already know the name of it. So we're just going to use the easy one here. And we're going to say department_text. db my collection drop index department_text. Number of indexes was 2. Status OK. Awesome. And that's it for this video. Hey, this is Nathaniel with coding-bootcamps.com again for another indexing video. In this section, we're going to pick up where we left off last time after creating and deleting an index, and basically show some different types of indexes that we can create. Mongo has a concept of something called a sparse index, and if you think about what we just did in the last video creating an index, we've basically asked Mongo to associate every record in our collection with its associated value of department. But what that means is that if a document or an employee, in our case, does not actually have a department defined, it will still get included in this index. So what sparse indexing does is it just tells Mongo that we only want to include in our index entries that have a value for the field we're indexing on, in this case, department. So if we look here, the documentation is pretty simple. We're actually going to create the index very similarly to how we did before, but we're going to add this extra parameter in. So if we go back to our CLI, we can go ahead and just scroll up to when we created our index, and this time we're going to create it with sparse equal true. And now if we list our indexes as we did before, myCollection.getIndexes, we'll see that we have our index here, name, department, text, and the sparse flag is set to true. Awesome. Let's go ahead and delete this index again. And now this time we're going to look at another type of index in Mongo called a partial index. So Mongo says that partial indexes only index the document in a collection that meet a specified filter expression. By indexing a subset of the documents in a collection, partial indexes have a lower storage requirement and reduce performance costs for index creation and maintenance. So in this case, what we can do is we can add this parameter, partial filter expression. We can add in a filter here that tells Mongo what data we actually want to index. So let's go ahead and do that. So we see that we have our partial filter expression here inside of our second parameter to the create index function. And now we need to define what is that filter. If we look back here, they were saying we want to filter on a rating that's greater than 5. Well, in the concept of this collection that we have, what if we filter so that we're only interested in a department of IT? If we look at our indexes, we see that we have a new index with a partial filter expression, department IT. Here's our command. Same thing as last time, creating our index on department. We got rid of the sparse configuration, and we replaced it with a configuration object for partial filter expression, which says we only want to care about records that have a department of IT. And now it's defined here. And what this means from a practical high level is that we have an index on all of our employees who are in department IT. That means we have a really quick lookup table where we can say, hey Mongo, I'm looking for everyone in the IT department, or I'm looking for everyone with a last name or with a first name of John in the IT department. And that filter, the portion of the filter that says in the IT department, Mongo can now just look at this index and say, well, who's in the IT department? Now I know I have a really quick lookup table. I don't need to scan over every record. I have these 5 IDs here. These are the 5 records that are in the IT department. And if there are any additional parts to that query, like give me everyone in the IT department who has the first name of John, well, the get everyone in the IT department part is done, and then it only needs to scan over those remaining entries to see who has a name of John. And of course, then you could also create more indexes on names and other things like that. So things can get complicated, but the important thing to remember is that indexing allows a quick
Thanks for watching. Please like and share this video.
lookup into our collections for specific data that we want. And it's really helpful when you're doing queries over large data or doing certain queries frequently, looking for a specific thing in your data. And with that said, we'll end the video. This is Nathaniel with coding-bootcamps.com on another indexing video. In previous videos where we created and deleted indexes, we ran the command to get indexes that belong to a collection. But this video is intended to take a step back, just talk a little bit more about this command, make sure that you're familiar with everything that this command provides for you. So if we look at our help that we had up here for collections, we see that we were using the get indexes collection. Now, this collection, or this command rather, does not have great documentation in here. So this is kind of a practical example too of showing how you can go and often find that information. So if we return to our browser here, we can go to search documentation, and we can, oops, copy the wrong thing. Going to go back to my terminal and copy this. We can just paste the name of this command, and we can get more detailed information on this. Returns an array that holds a list of documents that identify and describe the existing indexes on the collection, including hidden indexes, which, if we look back here and scroll down to where we got our indexes, that's exactly what this first index is. It's a hidden index. db.collection.getIndexes returns an array of documents that hold index information for the collection. For example, this looks very similar to what we see in the CLI. Index information includes the keys and options used to create the index. The index option hidden, available starting in MongoDB 4.4, is only available if the value is true. So again, if we go back here, we see that we have, and excuse me, I don't know if this is actually a hidden index or not. I may have spoken too soon, but based again on the documentation here, switching back, the index option hidden, available starting in MongoDB 4.4, is only available if the value is true. So based on that reading, I would think that there would be a hidden attribute here that's set to true, but I am not 100% sure on that. But we show here that we have ways of getting more detailed documentation, and per the documentation, we know that we have the type of the key that we're indexing on, which is text. We have the name of our index, and we have the expression that we're filtering on. And we also know from when we did sparse indexing, we would have a sparse flag here. And we have other information regarding the weight of the index, the language, the version of the index. And with that said, we'll continue on indexing in the next video. This is Nathaniel back with coding-bootcamps.com for another indexing video. And in this video, we are going to talk about compound indexes. Now, Mongo, per their documentation, say that they support compound indexes where a single index structure holds references to multiple fields within a collection's documents. This means that if we go back to our CLI in Mongo and go back into our database, this means that if we define an index that has two fields as keys for our index, then we'll only store records in our index that match both keys. So it's basically building a more complex index where, for instance, if we build the index off of department and first name, we'll have a unique index for IT and John, like all documents that have IT department and John as the first name. That will be different from the lookup table that we have for department IT and first name Jane. So it's a little bit more overhead to do it this way, but it provides you with a more efficient lookup if you want to just look up off of multiple search criteria, have an index for multiple search criteria. So what we're going to do is we're going to say db.mycollection.getIndexes just to see where we're at. We're going to go back to our help as we've done before, and we are going to look at the collection help by saying db.mycollection.help, and we're going to look at this same command that we used before, create index, and this time we're not going to use any special configuration as we did with sparse indexing and partial indexing, but what we're going to do to make this a compound index is we're going to say department text first name text. So this is the one JSON object we have as a parameter to our create index method, and we say that this index is for department and first name. So we'll get a unique entry into this index table per each record with a different department and text, as we talked about, or excuse me, as a different department and first name. So we're going to click enter, and we see we have an error here because I put quotes around first name, so I'm just going to remove those. And I have another error here. I apologize, but maybe it's helpful to see me messing up. So we see that now we've got it right, and we've got it in the right format: department, text, first name, text, and now we have a new index. And if we just show our indexes one more time, we see that we have weights for department and for first name, which again, I just really want to drive home. It's kind of a hard concept to understand. I highly recommend you read more into compound indexing, but we are creating a different entry in our index, a different thing to look up off of per the combination of department and first name. So we could have many different look up records that are associated with IT if we have a lot of people with different first names. So perhaps this is not the most practical index to do. It really just depends on the application. But that's something to think about. Again, it gets a little more complicated and advanced as you get into this type of concept in databases, but it's definitely very useful, and I highly recommend you read more into compound indexing. So with that said, we will close for coding-bootcamps.com with another video on indexing. In this video, we're going to be talking about unique indexes. So a unique index, per the Mongo documentation, is an index that ensures that indexed fields do not store duplicate values, i.e., enforces uniqueness for the indexed fields. By default, MongoDB creates a unique index on the ID field during the creation of a collection. And I alluded to that before. If we switch back to our CLI, we see that our list of indexes that we got back from our get indexes command has this first document here, which is a default index created by Mongo. And this index maps to the ID field in a document. And Mongo is telling us, per their documentation, that this is a unique index. It means that each document ID is only going to map to one document, which makes sense because it is, if you have done relational database work in the past, it is a primary key. There can only be one document associated with this ID. And we can indeed define indexes that have this same uniqueness constraint. So if we look back at our documentation, what Mongo is telling us is we can do the same exact create index command that we've done in past videos, but just give it this unique true parameter. So let's go ahead and do that. Let's go ahead back. Let's delete this index that we have here, just for simplicity. I'll drop department text. And it is actually going to be called, if you look up here at my cursor, because remember we created this on two fields, it's going to be department underscore text underscore first name underscore text. And now we're going to use our same create index, and we can go ahead and continue to use the multi-valued combination of department and first name for this index, and just paste in this constraint unique true. And actually this is a little bit of a more practical way of creating this index, because if we create this index just with department as the key, then that's saying that we can only have one matching document for each department. So it's saying we can only have one employee in the IT department, for example. So by doing this on the multi-valued index, we're saying we can only have one employee in the IT department with the first name of John, for example. So we click enter. And we see that we have an error that has shown up here. Duplicate key error collection. And it appears that we perhaps already have an index here. I thought we had deleted it. So let's look. We do indeed only have our one index. So let's try that again. And this is actually very interesting. I didn't expect to hit this, but it makes sense. If we go back, this is a really good learning opportunity. If we go back to our JavaScript, if we look at our employees, remember what we just talked about. We're saying that we can't have two employees in the collection called My Collection that belong to the same department and have the first name. Well, in a prior session, we had created 2 Tom Wilberts to illustrate that we were able to deduplicate a record and delete a duplicate record. So right now, we still have 2 Toms. So we have 2 people in the IT department with the same first name. So let's try this. Let's just get rid of one of these employees here in our script and save the file. And again, just remind ourselves what's going on here. We're deleting everything in our collection, and then we're going to.
Thanks for watching. Feel free to add your questions as comments down below.
Add all of our employees, our 4 employees, but not employee 5. So now we're only going to have 1 Tom in the IT department. And we can even go ahead and comment out this aggregation if we want to, but it's fine to let it run. The important thing is that the data gets in there with just these 4 employees and without a duplicate Tom. And we could do this, we could delete our second Tom from the CLI, but it's going to be easier to do this from our script. So we'll go ahead and run our script again. Go back into the Mongo CLI, and we'll try creating that index again. And we see it's successful. It's able to create the index because it's not seeing that there are 2 people named Tom in the IT department. Great. And we'll pick up where we left off in the next video. Nathaniel with coding-bootcamps.com, and in this final video we're going to talk about converting the type of a field through an aggregation. And I've written out an update to our aggregation.js file that we've been using throughout the past couple of sessions. And as you can see here, we have our same aggregation pipeline. And this time what we're doing is we're using a new operator called add fields. And we're going to add in for each of our documents in this collection a new field called converted salary, and we're going to say that converted salary is going to be equal to the conversion operator and its specification here, which as a whole is saying the field salary in our employee converted to a string. So this whole thing here becomes our new converted salary field on our employees. And we'll print each one out as we go along. So if we save this and we go back to our terminal, and go ahead and clear for some space here, and we hit our same trusty script, we'll see here, if we scroll to the top, we have all of our employees. Each employee still has their salary field. They also have a converted salary field. Notice that the first salary field is the original integer value, and the new field that we created called converted salary is that same value but as a string. As you can imagine, this is really handy tool to be able to migrate data if you have to change the type of data in your collection. And when your migration is complete, you have your new field with your new type, and you've updated any applications or anything else using your database to use this new type that you want, then you can delete the old one. And with that said, we will close out this session and the course. Thank you so much.
Hey, this is Nathaniel again with coding-bootcamps.com, and we are at the end of the NoSQL programming course. In this course, we learned how to create and manage NoSQL databases. And just to remind you, here is what we did this course. We got started with MongoDB, with the Mongo CLI, and writing a short JavaScript to interact with our database. We talked about CRUD operators and getting database information, viewing your databases, your collections, those types of things. We talked about querying for data using find, specifying different search parameters to get the data that we want. And we talked about updating our data. We talked about inserting and upserting our data. If you remember, upserting being inserting something new or updating something that exists. We talked about collections in detail, how to get help on collections from the Mongo CLI, how to create drop collections. We talked about aggregations, building that aggregation pipeline, which got to be a little more advanced. And then we talked about indexes, and we talked finally at the end about bulk operations, converting that type of a field on our employee document that we had been storing in our Mongo database. So congratulations, you have successfully finished this class, and I really thank you for making it all the way through. I really hope you got a lot out of the course. And if you are interested in more courses, please consider choosing from one of these. We have a lot of really great courses here at coding-bootcamps.com. And with that, I will just say thank you one more time. I really enjoyed teaching the class. I loved going over the content, and I hope you get something out of it. So with that said, I will see you in the next class. Take care. Bye-bye.